welcome back to Tech with Host. In this video, we're solving the first two problems from Codeforces Round 1107, Div 3. We'll cover problem A and problem B. Both problems are beginner friendly, but each takes a very different way of thinking. Problem A is all about finding a simple mathematical observation. Problem B is a constructive problem where one beautiful pattern solves everything. So let's begin. Problem A, divide and conquer. We're given, let's understand the problem. We're given two integers, x and y, in one operation, which is a divisor of x, and divide x by it. We can repeat this operation as many times as we want. The question is like, can we transform x into y? Which means determine whether you can make x equal to y using one operation. So their input, so input contain a single integer t, number of test case, the description of the test case follows. The only of each test case contains two separate x and y. So print yes if you can make x equal to y, no otherwise. You cannot put yes, no in any case. So we can let's see, we can implement it in a simple way, but let's see the visualization process. So for today's, we're doing for problem and for problem B. So for that, I'll do like today's agenda, problem and problem B. We see the code explanation and the complexity also. So divide and conquer problem is a problem statement where given x and y, and we're reaching. Can we reach from x to y? So if it is yes, if it is not, no, we can say just like that. So 12 is equals to 2 times 3. We can go through 12 because 12 is a divisor of 2. So remove one factor, 6, remove another 3, and 2, we only remove factor. So a big takeaway from this observation, every reachable number must divide x. So every reachable number must divide x. So we can get the answer by this flowing chart. It is simple. If x is divisible by y, we can say yes, otherwise no. This is the final answer for the first problem. Let's see the implementation side within a Python. So to complete, we need to get an input for the number of test cases. Based on the number of test cases, we use a for loop. For a range of t, we use n comma m, or you can say x comma y, map and input data split. Yeah. Then after this, if, as we said, if n modulo m is equals to 0, it's divisible by y, or you can say m, print yes. Then after that, the else part becomes print no. Yes. Let's run it. So we can say run, I think 3, 12, 2, 6, and 7. Yes, no. The other one is 99 and 79. 99 and 79. So it's no. So the final answer becomes this one. Submit. For dividing here, just paste it, and you can submit it, and you can get acceptance for this one also. Now let's move to the problem B. It says the title is good times. For understanding the problem is important. A number is called good if it contains at most two distinct digits. So, which means, for example, we're given like 3 as have one distinct digits, and 8588 also have the same. So they're good. 67 also good, but 123 and no 9447 are not. You're given X, which is good. Your task to find is an integer. Our task is to find a good number y. So that y is good, and X time y also good. This problem is, I think, on this one, if there is multiple valid answer, output any of them, which means this usually means there's a clever constructed solution. So I tried a lot of things, but actually to find the efficient and the best solution is constructed solution. Let's see how on the visualization. This good times problem. What is good? Firstly, as we said, good is a number good if can be split into two equal halves whose digit halves are copy of each other, which means like there is not be much two distinct digits. So it is have one distinct digit, 67 have two distinct digits only, and 220 299 also the same, but 123 is not, and 407 is not because they have uh, three distinct digits. The challenge is given x, find y such that y is good. Let's satisfy the good number rule. X times y is good. Uh, to satisfy the Bowles condition. So first my attempt was is like you using one number like 11. When you use 11 you can get a good number always, is my first assumption, but it's not good because when you say it's 8 times 11 is 88, but when you see 73 you can see it's 11 is 803, and it doesn't give you a good because it mixes three different digits. So finding just like one number or something is not a good. So you need to have a constructive algorithm. Year before, I got some kind of just like this question is the same as this one, and it have a good pattern. So uh, as always, if you solve on Corpus a lot of problem, it gives you a pattern and you understand the problems in easy. And so find the pattern for this one is getting the number of digits in the top 10 the power of the number of digits and plus one, and then multiply it by what one is given your solution for the this problem also. So here's the magic formula that I get from the another problem, the pattern for this problem also. So you need to have a k digit. So let's say 299 is have three digits. So you need to have 10 to the power of 3 is 1000 plus 1 is 1. For that matter, we return 1001 is the our solution for this one also. So for that matter, and we need no carries, no digit overlaps, and digits repeated. Because for why is it work is because no carries, no digit overlap, and the same digits repeated for that matter. So we can check it. We when we multiply the two number, also it's not it's a good integer. So both the y and the derivativity is good. Another example, you can see it and you can do a lot of test cases you can write and check it. It is work. It will work for you also. So the algorithm is simple: read X and count the digits and compute the power, and from that power, that's the real. So the complexity becomes of log X, and the memory is also of Y. Let's see the implementation side. So for this one also, I take an input because there are multiple test cases for that one. So input. After this, I just use for loop and for in range of sorry range of t. After this, we take one integer, one string. So after this, we stripe, and after that, I need to calculate the power. For that, I use k, that k number, which means length of str of n. After this, I need to calculate the solution. So I said y and 10 the power of k plus 1, and that print y. Yeah, I just give one for 8. It's 11. So it works. You can try it and you can submit it. This one adds something for the two problems, the time complexity and the space complexity for the two. The first ones are is constant time and constant space, because we don't use any extra space. For this one also, we use counting for that purpose using log x. So everything else is constant time. So the total time complexity is of log x with constant extra space. So today's we solved two completely different types of problems, and problem is taught as simple mathematical observation. Problem B showed us recognizing a pattern from the previous problems, and this is one of the most important skill in complex programming. The more problem you solve, the better you become at spotting these hidden patterns. If you let me know in the comments if you'd like to me to continue solving the remaining problem from the contest. So thanks for watching.